Welcome to this revision for the revision class. I'll be taking you questions on strictly on enzyme kinetics. This enzyme kinetics, these enzyme kinetic questions, these are likely questions, not likely questions, but they are similar to what you can be able to find anywhere in the world, or perhaps even your soon coming exam, your coming exam, you can just borrow one idea or the other from it to help you scale through. So that's why I'm taking three different questions that will address different thing, almost the same thing. So just pay attention so that you can be able to get the best out of it. These are the questions I've provided for you. Now, if questions like this will come out, I'm going to provide you the constant values, the R value, the T values, and essential questions that will help you to answer the questions. So looking at the first question, it talks about lactic dehydrogenase and what does it do? It's transfer hydrides. Now, we are asked to calculate the standard free energy for this reaction and also the substrate concentration of the reaction. And for you to be able to calculate the standard free energy, you need your Gibbs free formula, which is delta G equals to minus RT ln KUQ. So as for your RT, I will provide them if you have them in exam. And the only condition whereby you change your T is if the reaction is not carried out in at room temperature. For instance, if the temperature is 37 degree, that means that you need to add 37 plus 273 Kelvin to give you 310 Kelvin. But this one is occurs at room temperature, that's 25. So 25 plus 273 will give you 298 Kelvin. So that's converting it. And by the time you key all the parameters and the information provided in the above question into the formula, you'll be able to get your Gibbs free energy. Then that's the standard free energy. Then also to calculate your substrate concentration, remember your equilibrium constant equals to the reactant, the product reactant over the substrates, or the products over the reactants. So, and for the product we have the enzyme and the product, and for the reactant we have enzyme and the substrate. So looking at it mathematically, you delete the enzyme on top and the enzyme below, which is, because they are of the same concentration, they cancel out each other, just like they still obey the rules of mathematics. So that's what you do. Then you're now fixing the concentration of the product over the unknown, whereby that's the substrate concentration, that's the one we are looking for. Then you make the substrate concentration the subject of the formula and put your key KUQ beneath the product, and that's how you'll be able to get 22 millimolar. Now the next question is calculate the maximum velocity for the enzymes. In this case, you can either use Michaelis-Menten equation or Weaver-Buck equation. But Michaelis-Menten equation is provided here, which is V equals to Vm multiplying the substrate concentration over Km plus the substrate concentration. By the time you make Vm the subject of the formula, this is what you get. And just by the time looking at it, you see that all the variables, sometimes when you are doing this kind of calculation, use the what's it called use the it's either of the two way. Either you use the unit alongside, or you master or memorize the unit, so that at the end of the day you just put the unit and you'll be able to get it. And that's how we were able to get Vm equals to 10 raised to power minus 5. Once you use your calculator, you'll be able to get this one. Now for the Vm equals to V times Km plus substrate concentration. Always remember the rule of BODMAS. For you to be able to address this question, remember BODMAS is bracket first. So you first of all solve that of the bracket, that's 33 plus 22 millimolar. You understand that the same unit, so you go and then after you do bracket first of division and likes, so that you'll be able to solve the above, that you'll be able to do everything to get together. That's how we get 10 raised power minus 5 millimolar per second square. So we also have that of the kcat. Your kcat is your maximum velocity over e what's it called, total enzyme concentration used. Remember, there's something that is many people are confused about. When the total enzyme provided for you is 5 nanomole or nanomolar or mole per bill, your mole per bill is equals to molar, equals to molarity. So if they use nano, that means 5 times 10 raised power minus 9 molar. If it's micromole mole per mil, it means it's 5 times 10 raised power minus 6. If it is milli, it is 5 times 10 raised power minus 3, and the likes like that. So please always pay attention. It can come in various angles, so that you'll be able to get the right concentrate, the right what's it called, the right um the right indices to use. Look at this one: 5 times 10 raised power minus 9. They were able to use it, and the final answer is 2 times 10 raised power minus 3. So please pay attention to the what's it called, the formula, your indices. If you don't know indices, the little indices I can tell you is that it was the what's it called, once the digit is going from alternate across a division, it becomes minus. Are you getting me? Subsequently, I will show you, so that you'll be able to have a full grasp of the indices through this example. Then we also have that of catalytic efficiency. Your catalytic efficiency is kcat over kn. Your notes have taught you what your catalytic efficiency is. Your catalytic efficiency, your Km, you should all know the importance of this Km in relationship to your enzyme. These are things that as a biochemist you need to have them handy. So we've derived our Km, we've derived our Kcat. You can put them together and you'll be able to get your answer. Now look at the indices that play out here. We have our Kcat as 2 times 10 raised to power minus times 3, and we have our Km as 33 times 10 raised to power minus 3. Now look, when the minus is going up, it became uh, it became 10 raised to power 3 minus 3, if you are going to do it step wisely. So that minus, we nullify that minus, which will be 3 plus 3, that's 6. So whatever the answer will be, the answer is in decimal times 10 raised to power 6. But because it's in decimal, by the time you move 2 decimal places, you have 6.1 times 10 raised to power minus 2 plus 10 raised to power 6. By the time you subtract it, we have 10 raised to power 4. That's how we got this. So the question is, does your lactate enzyme approaches your catalytic perfection? You'll be able to know that because I've given you notes for your catalytic perfection. Your enzyme must be in the range of 10 raised to power 8 to 10 raised to power 9 molar per second. So these are things you need to look. I think the other ones are very, very easy for you. The S there stands for enzyme, the S stands for substrate. Don't forget, just go through it, you'll be able to get it. Then what is your Km? Your Km measures the substrate, measures the affinity of an enzyme of the substrate. The lower the Km, it means that your Km it tells you that the lower the Km tells you that your enzyme have greater affinity for your substrate, better. So any enzyme that have low Km, it means that it is capable of reacting very fast, or having what's it called, uh, having the ability to go straight into reaction without any hindrances. So that's the significance of Km. So look up your notes, so that you can be able to get those things that you need to be able to understand this. Now the next the next example that I want to give you is that I give you a graph to the example. Now, in case you are given a graph of Lineweaver graph, I've provided you a function of Lineweaver which we will use for this for the purpose of this explanation. But let me first of all explain a Lineweaver graph for you. A Lineweaver graph is formed from the inverse of Michaelis-Menten, and so the graph is plotted as 1 over the velocity, inverse of the velocity over inverse of the inverse of the substrate concentration. Now, looking at it, the intercept on y-axis will give you 1 over v max, while the intercept on x-axis is will give you minus 1 over km, and why the slope equals to km over Vmax. So these are the important things you need to know. So your slope equals to km over Vmax, your intercept on the x-axis is minus 1 over km, and your intercept on the y-axis is 1 over your Vmax. These are the variables that most times people need to know in order to be able to give appropriate information for about your enzyme. Now, for instance, now I've given you an equation which is y equals to 16.9774 x minus 1.572. Now, if you want to look at this question, we are asked to calculate your Km, your Kcat, and your catalytic efficiency. You've also been provided with the total enzyme concentration, which is 8 micromole per mil, which is 8 micromolar. You know, I told you earlier on that your mole per mil equals to molarity. Now, looking at this function, you simply equate the function to y equals to mx plus c, and you are asked to calculate your km. Now, looking at it, the intercept of this graph on the x-axis equals to intercept equals to minus 1 over km. So thereby your c of the equation, which is minus 1.572, we should note that you just simply equate minus 1.572 equals to minus 1 over km, and by the time you multiply minus to everything, it will cancel out the minus, and you'll be able to have 1 over km equals to 1.572, and your km equals to inverse of 1.572. Thereby, at the end of the day, you'll be able to have a km of 0.634 millimolar. Now, the next question is, what is your Kcat? Remember, your Kcat is your Vmax over total enzyme. Now, the question is, we don't have our Vmax. How do we calculate our Vmax? Remember your slope, which is equals to km over Vmax. And looking at the equation of a straight line equation, y equals to mx plus c, equate it here, you'll be able to see that your slope is 16.9774, and you've known your km already. Therefore you have your your Vmax equals to km 0.634 over 16.774. then you'll be able to get your Vmax. Then therefore your Kcat equals to Vmax, which is 0.074 over 8 times 10 raised to power minus 6. You remember it is in micromolar. So you do that and you'll be able to work with your indices, and you'll be able to get 10 raised to power 3. So if you don't know your indices, I think this is the best time for you to do it. Now, for catalytic efficiency, which is Kcat over Km, just follow the same principle. You've known your Kcat, you've known your Km, just plot it, obey the rules of indices, and you'll be able to get your final answer. Now, the next one is that you are provided a variable. That's question 3. You are provided various variables. If you don't know how to make Km the subject of your formula, just plot in the digits and compute like that. The final answer, you'll be able to get it, but you have to be very, very careful. Now, there is something I did here that some of you may not be able to understand. If you look at the maximum velocity, your Vmax is 18 micromolar. Your initial velocity is 2 micromolar. But when you look at the total concentration of the phosphoric acid, it is in 2 times 10 raised to power minus 5 molar. And what I did in the equation, because you will see that your Km, Km multiplied by 1 over V max multiplying the substrate concentration beneath. I don't need to. The thing is that Km times 1 will be Km, while underneath the denominator you say 18 times 0.2. Why? Because I've converted my 0.2, the 2 times 10 raised to power minus 5 to micromolar, so it is now 0.2 times 10 raised to power minus 5. And by the time I multiply those two, I was able to get 3.5. While the fractions ones, I put them together to be able to get my fractions right. And at the end of the day, I was able to get Km equals to 1.584 micromolar. So please just pay attention to it. The indices are good for you to be able to remember. I don't think there's any question, anything that is difficult here, only that you just need to pay attention. Like I said earlier on when I came to your class, you need to be able to prove your Michaelis-Menten equation related to your what's it called, your Lineweaver-Burk, or better still, write out important formulas that you need to know. And once you know those formulas, by the time you come inside the exam, or if the questions pop up, you'll be able to answer. So like all the past questions I believe you'll be seeing, question 1 is very, very compulsory, and is very, very important as an enzymology to be able to tell about the properties of an enzyme, to be able to give information about your enzyme. So I wish you all the best. Try as much as possible to prepare. If you are not yet clear with this, just go through my subsequent videos to be able to look at how I arrive at the Michaelis-Menten equation to the Lineweaver-Burk. All my videos is not up to 1 hour, so at least 1 hour for you to cover my aspects in enzymology will not give you problem. At least it will be an added advantage. And please, as much as possible, jot review questions and likes. Then don't things can get twisted, but just calm yourself. Like I said, once you are given a question, write out your variables and try to determine, okay, which formula is best that can best address this question. So with that, I believe you'll be able to do well. I wish you the best as you prepare for your exam.